first example. We're just going to dive off the deep end here. Okay, so we have this equation, and here's what we know. We know somebody took the absolute value of something, then they multiplied it by 3, then they subtracted 5 and got an answer of 10. So all we really care about is we care about what the absolute value is. We're solving absolute value equations. We don't care about the rest of whatever this person did to get an answer of 10. So the first step, what we need to do is we need to isolate the bars. Please write this down, because here's what I have seen mostly. I have seen you do this with me, and you're all good, and I'm walking you through this, but like when you go and do it by yourself, you might get tripped up. Please write down these steps with me. Guys, when I say bars, I talk about the absolute value bars. We don't call them lines. We call them bars. Speaking of bars, I can never distribute across a bar. So that 3 is never going to get distributed to inside any bars. So let's go ahead and isolate the bars. Let's go ahead and subtract 5. And then we're going to divide by 3. Let's add 5. Let's add 5 to both sides. Get rid of that negative 5 over there. So now we got a 15 over there on that side. And now what we're going to do is divide everything by a 3. So remember, these 3's cancel out because that was just one term. So we're going to have 4x minus 1 in the bars, and that's going to equal a 5. That's all we care about. We just care about what's going on with absolute value. So we know inside the bars has an absolute value of 5. There's only 2 things that can be in there. A positive 5 and what else? That's right. So we have to solve twice. So now that we've isolated the bars, the next step is to solve for the original and the opposite. So absolute value equations are kind of like bargain equations. You guys are so lucky, because when there's only one of these, you get to solve them twice. 2 for 1. Oh, that's an and sign. All right, so here's what I'm talking about. When I say the word original, I'm talking about the original parts in the bars, like this. I'm going to drop the bars. That's a 4x minus 1. That equals 5. But remember, you have to solve it twice. It could also be the opposite. So y'all, take a look at what I did up there. I have 2 things going on. We're going to work out 2 problems. We're going to work out what was originally in there. Then we're going to work out the opposite of what is in there. Never, ever, ever, ever mess with the answer. Never change the sign of the answer. You only change it in the bars. All right. So let's go ahead and solve for x for how it was originally written. Add 1 to both sides. Divide both sides by 4. So I have x equals 6 over 4, but I'm not writing that. Y'all got to simplify. What does that simplify to? 3 over 2. That's right. Good job. All right, now let's go ahead and knock out the opposite. Guys, you got to distribute the negative. So if it was originally a positive 4x in there, we're dealing with a negative 4x now. If it was originally a negative 1, we're dealing with a positive 1, and it still equals a 5. Don't mess with the 5. Okay, let's solve for this side. So subtract 1 on both sides. So we get negative 4x equals a 4. divide both sides by -4, and x on this side equals a -1. New notation. So please put -1 first, because we write them in order from least to greatest, and then write your 3/2.